we'll start with the first four because they're all asking the same thing. They're all asking for how many outcomes in each situation. The first one is flipping a quarter. Okay, what could you get? You can get heads or tails. Heads or tails is going to be two outcomes. You got two choices. Number two, it's actually the same thing. True or false. How many outcomes? Two. Number three, rolling a standard number cube. If you didn't know what that means, they're just talking about a dice. And on a dice, there are 6 sides, 6 numbers, so there's 6 different outcomes. And then choosing a month at random. Let's say we just wrote every name of the month on a slip of paper and put it in a hat. We drew it out. How many outcomes would we have for months? Well, there's 12 months, so there's a possibility of 12 outcomes altogether. All right, here are all the questions to 5 through 12, and if you notice, I just put a fraction beside it out of 10 because every single one of these things is going to have 10 possible outcomes. If you've got 10, what does it say, 10 cards, 1 through 10, you've got 10 possible choices, so your bottom number is going to be 10 no matter what. Now we just need to go through and see what are our odds or what are our chances of each one. So the probability of drawing a 1, there's only one 1, so it's 1 out of 10. The probability of drawing a multiple of 3, so that would be a counting by threes, so we'd have 3, 6, 9, 12, there's no 12, all we have is 3, 6, and 9, so that's 3, so our chances would be 3 out of 10. If we're doing 2-digit numbers, 10 is the only 2-digit number, so that's going to be 1 out of 10. The probability of getting a 6 or a 2, okay? Well, there's only one 6 and there's only one 2, so that's 2 out of 10. 2 out of 10 there. Probability of getting a 12. This is one of those ones that is never going to happen, okay? 0 out of 10, which equals 0. Remember, it can never be less than 0, but 0 is the lowest probability you can get, meaning it's never going to happen. You can't get a 12 here. Less than 11. Okay, this is a case where it's one whole. 10 out of 10. You're always going to get something that's less than 11. So this equals one whole. Remember, you can never have anything that's more than one whole. Probability of getting an odd number. 1, 3, 5, 7, 9. There's 5 odds, so that's going to be a 5 out of 10. We can, a lot of times people do this, because it makes it easier to interpret and easy to read. 5 out of 10, if we reduce fractions, find something to divide into both of those, I could divide 5 into both of those. 5 divided by 5 would be 1. 10 divided by 5 is 2, and we have a 1/2 chance of getting an odd. And then the probability of getting a 5, there's only one 5, so again, just like the probability of getting a 1, there was only one 1, they're both 1 out of 10. This time we've got a number cube or some dice. And again, the outcomes. For dice, there's 6 outcomes no matter what, because there's always going to be 6 possible choices. So I can just put that to start with. Probability of rolling a 6, 1 out of 6, 1 6 to choose from. Probability of getting an even, 2, 4, 6 are all even numbers. That's 3 out of 6, which is the same thing as 1/2. The probability of getting less than 6, everything up here, I guess it does say less than 6, I better change that. Less than 6. 6 isn't less than 6, so we can't include that. So we'd have 1, 2, 3, 4, 5, so that would only be 5 out of 6. I was thinking if it would have said 6 or less, you just have to kind of think of the wording, then it would be all of them, but since it's less than 6, we've only got 5 of them that are less than 6, so it's 5 out of 6. The last one, probability of 7, that's never going to happen. So that's one of those 0 chances right there. It's never going to happen. So that would be 0 out of 6, or you could just put 0 would be fine. This one, like the last one, is also going to have always a probability, or has outcomes of 6, because we've got 6 different things we could draw from here. So I'm just going to put 6's under all these. Alright, probability of getting an A, there's only one A, so that would be 1 out of 6. Probability of getting a C, there's actually 2 C's here, so that would be 2/6. I could reduce that down. Think about what goes into 2 and 6. 2 is the only thing that does. Divide by 2 and I'd get 1/3. Probability of getting a vowel, you got to know what that means. A, E, I, O, U. So we've got A and E, so that's 2 out of 6. Consonant is everything else. C, H, and C would be 4. So we've got 2 out of 6 and 4 out of 6. Here's something to notice here. Look at these two. If you draw letters out of here, you are either going to get a consonant or a vowel. Okay? Those are like your two choices, basically. So if you really look at this, if you put the amount of vowels together and the amount of consonant chances together, 2/6 plus 4/6 is going to be 6/6. So if you have an either or situation where you can get vowel or consonant, head or tail, if you add those chances together, you'll always get one whole chance or a certain. So if the question was changed to probability of drawing a vowel or a consonant, okay, of course, since you've only got two different things to choose from, that's going to be one whole. Right, the very last two for 27 and 28, we're looking at the chart that they have there dealing with eye color. And the one thing that you'd need, because this one isn't so cut and dry as far as outcomes goes. Now, the problem tells you there's 32 students. So automatically I know if there's 32 students, there are 32 different outcomes. Okay? If you didn't know that there are 32 students, we would just have to go down to the graph, which goes by twos. Remember, that's called an interval. It goes by twos, and just count to see each one and figure out how many we have total. We've got 2 in the other category, 3 in the green, 9 in the blue, and 18 in the brown. When we add them together, we get 32. So our first part is the probability of getting a blue. It looks to me like there are 9 blues, so I can just do 9 over 32. I don't think there's anything that goes into both 9 and 32. 3 would be the only thing for 9, and I know 3 doesn't go into 32, so we would just keep it like this. We have a 9 in 32 chance of, if we picked a student at random, them having blue eyes. The other one, brown or green, so we need a combination. Brown is 18, green is 3, so altogether we would have 21 out of 32. So if I picked a student out of random in this 32-person group, there is a 21 out of 30 chance that their eyes are either going to be brown color or green color.